Hello everyone! Welcome back once again to Doc GILMAC online tutorial. Grade 7 Mathematics tutorial. The topic I'm going to discuss for today's tutorial is all about illustrating rational numbers. Before discussing the topic for today's tutorial, let's have first a simple recall on division of integers. Now let's have a warm-up drills. Divide the following. Number 1, 40 divided by negative 8. Take note, you are dividing two unlike signs. So the quotient is negative. So this is just equal to negative 5. Number 2, negative 28 divided by negative 4. You are dividing two like signs, so the quotient is positive. Yes, it's positive 7. Number 3, negative 33 divided by 11. You are dividing two unlike signs, so the quotient is negative. It's negative 3. Number 4, 72 divided by negative 9. You are dividing two unlike signs, so the quotient is negative. It's negative 8. Number 5, 51 divided by negative 3. You are dividing two unlike signs, so the quotient is negative. It's negative 17. Now consider another warm-up problem. Patrick works twice as many days as Leon works each month. Leon works 4 more days than Jimmy. If Jimmy works 10 days each month, how many days does Patrick works? Consider the given condition in this particular problem. Jimmy works for 10 days in a month. Leon works 4 days more than Jimmy, which means he works 14 days. Therefore, Patrick works for 28 days since Patrick works twice as Leon works. A rational number is any number that can be written as a fraction p over q, where p and q are integers and q is not equal to 0. Any fraction can be written as a decimal by dividing the numerator by the denominator. If the division ends or terminates because the remainder is 0, then the decimal is a terminating decimal. So take note of that. If the division leads to a repeating block of one or more digits, where all digits are not zeros after the decimal point, then the decimal is a repeating decimal. A repeating decimal can be written with a bar over the digits that repeat. So 0.1333 is just equal to 0.13 bar notation. So take note of that. Illustrative example number 1. Write fractions as decimal. Write the fraction as a decimal, given 11 over 9. Now, let's divide 11 over 9. 11 divided by 9, so we have 1. 1 times 9 is 9. Then 11 minus 9 is 2. Bring down 0. 20 divided by 9 is 2. 2 times 9 is 18. So as you can see, the remainder is 2. So which means the pattern repeats. This is an example of repeating decimal. The fraction 11 over 9 is equivalent to the decimal 1.2 bar. Now, let's have illustrative example number 2. Write fractions as decimals. So, given 9 over 20. Again, let's divide 9 divided by 20. 9 divided by 20 is 0. It cannot be. So, we have 90 divided by 20. So, we have 4. 4 times 20 is 80. 90 less 80 is 10. Bring down 0. So, it's 100. Then, we have 5 times 20 is just equal to 100. The remainder is 0. So, therefore, this is an example of a terminating decimal. The fraction 9 over 20 is equivalent to the decimal 0.45. Now, consider example number 3. Write the fraction as a decimal, 17 over 9. So, let's divide 17 divided by 9. We have 1. 1 times 9 is 9. 17 minus 9 is 8. Bring down 0. 80 divided by 9 is 8. 8 times 9 is 72. So, we have a remainder of 8. As you can see, the pattern repeats. So, therefore, this is a repeating decimal. The fraction 17 over 9 is equivalent to 1.8 bar. Now, let's have illustrative example number 4. Given the fraction 9 over 40, you write the fraction as a decimal. Let's divide 9 over 40. Cannot be, so we have 0. Then we have 90 divided by 40 is 2. 2 times 40 is 8. So bring down 80, I should say. Then subtract 90 by 80, so we have 10. Bring down 0, so 100. 100 divided by 40 is 2. Then multiply 2 by 40, we have 80. Subtract 100 minus 80, so we have 20. Bring down 0. 200 divided by 40 is 5. 5 times 40 is 200. The remainder is 0. So therefore, this is a terminating decimal. The fraction 9 over 40 is equivalent to 0.225. So take note of that. To write a terminating decimal as a fraction, identify the place value of the digit farthest to the right. Then write all of the digits after the decimal point as the numerator with the place value as the denominator. Let's have an illustrative example number 5. Writing terminating decimals as fraction. So this time, it's the exact opposite of the 4 given examples a while ago. 0.8 is in decimal form. We write this in simplest form of a fraction. 0.8. 8 is in the 10th place. So write tenths as the denominator. So we have 8 over 10. Let's reduce. So that's just equal to 4 over 5. Take note, 0.8 is just equal to 4/5, which is the fraction in simplest form. The equivalent fraction of 0.8 in simplest form is 4/5. Let's have illustrative example number 6. Write the given decimal as a fraction in simplest form, 5.25. 5 is in the hundreds place, so write hundreds as the denominator. So 5.25 is the same as 5 over 25 over 100. 5 and 25 over 100 is the same as 5 and 1/4. Okay, 25 times 1 and 25 times 4, cancel 25, so we have 5 and 1/4. Okay, so take note, 5.25 is just equivalent to 5 and 1/4 fraction in simplest form. Let's have illustrative example number 7. Write the given decimal as a fraction in simplest form, 0.625. 5 is in the thousandth place, so write thousands as the denominator. So this is just the same as 625 over 1000, or 25 over 40, or 5 over 8. Take note, 0.625 is just equal to 5 over 8 fraction in simplest form. Remember, a fraction is in reduced or simplest form when the numerator and the denominator have no common divisor other than 1. Let's have an illustrative example on writing repeating decimals as a fraction. So 0.6. 6 is in the 10th place. So we have 10 minus 1 is the denominator. So 10 minus 1 is 9. So we can write 666 over 1000 since repeating decimal. Okay. Or simply 0.6 is 6 over 9 or 2/3 fraction in simplest form. So this is just the shortcut way in converting decimal, repeating decimal in fraction. Okay, take note, 0.6 is in the 10th place. So you just subtract 10 minus 1. So we have 9. So 6 over 9 or 2/3. Now let's have another example. Illustrative example number 9. Writing repeating decimals as fraction. Write the given decimal as fractions in simplest form. Take note, 0.52 is a repeating decimal since we have here a bar notation. 2 is in the hundredths place. So you just subtract 1 from 100. So 100 minus 1 is 99. You take that as your denominator, and the numerator is simply 52. So we have 52 over 99. A fraction in simplest form. So this cannot be reduced. So this is just our final answer. 52 over 99. Again, I would like to thank you for watching. Stand by for my next tutorial, and may God bless us all.